Hi again. We will continue our studying for complex numbers. Okay. The previous lecture we have talked about basic operations for complex numbers. Okay. In this lecture, we will talk about the magnitude and angle for the complex number again. And we will also talk about the real and imaginary part of complex number, and the last thing will be Euler's identity. Okay, so let's move on. So if I define C as 1 plus I, okay, this is it, and I want the magnitude for this complex number. I just type no, it is not like this. It is not like that. We just type abs or absolute, and we will pass the variable which is C. So what basically MATLAB does is finding the Pythagorean theory for this, which is 1 squared 1 to the power of 2 plus 1 to the power of 2, all under the square root, which is 1. Oh no, 1 plus 1 is 2, which is square root of 2. Let me check. See, the same result. And if we want the angle between the angle, so we just type angle here, just like that, and here it comes as radians. If we want it to be in degrees, here multiply it by 180 over pi, and this is what we expected it to be, because the real part is 1 and the imaginary part is also 1. The angle between them should be 45. Okay. So let me clear this screen. So if I want the absolute or the magnitude for this number, again 1 squared plus 32 squared all over the square root, and this is the value. Okay. If I want the angle between them, which is basically the inverse tan between this over this, we have to type it again, 1 plus 32i, and this is the answer in radians. Maybe we want it to be in degrees over by the pi goes with pi, we left with degrees. Okay. So let me recall A, which is this. If I want to get the real part and the imaginary part, we literally type real, pass the variable or the complex number here, and as we expected it to be, it is 2. Okay. If I want the imaginary of A, okay, so it might be like this. Okay, it is minus 3, and that's it. Okay. So why would want to know the real and imaginary part. In our next lectures, the advanced topics or before them, basic elementary or elementary programming in MATLAB, we will mostly use them, the imaginary part and the real part. And if we didn't do that, you will encounter a problem and you just want to take the real part or you just want to take the imaginary part. So you will need them. I can guarantee that for you. Okay? So clear the screen. And the last thing we want to talk about is the Euler identity. Okay, so what is the format of Euler identity? It is R E of I. So let me type it here. Of say 1 multiplied by I. So if we type something like this, what might be what MATLAB will understand? Okay, so it is converting it from the Euler form to the rectangular form. So how that happens? Okay, basically it is cosine the angle plus I sine the angle between them. Okay, that's the Euler identity, and that's how to convert it from rectangular to Euler. So if I want the angle between them, the exponential of 1, or let it be 2 multiplied by I. So what would be the answer? Okay, the angle will be always this number before I. So I guess let us type something else. So why